For a 5 kV service at 2 amps, the minimum wire size according to the National Electrical Code, or NEC, is firstly 14 American wire gauge, or AUG, for copper, and secondly 12 American wire gauge, or AUG, for aluminum. Stress cones are required when the wire is terminated on high voltage equipment. They distribute the electrical stress along the insulation to prevent arcing and insulation failure. In this case, the wiring is not directly connected to the high voltage equipment, which is the 5 kV bus. Therefore, stress cones are not required. The wire should have cross-linked polyethylene, or XLPE, or ethylene propylene rubber, or EPR, insulation, which is suitable for high voltage applications. The wire should have a suitable jacket material such as polyvinyl chloride, or PVC, or low smoke zero halogen, or LSCH, for protection against environmental factors. I recommend using a 14 American wire gauge, or AUG, XLPE insulated, PVC jacketed copper wire, or equivalent. Furthermore, utilize appropriate fusing and circuit protection devices. It is important to follow all applicable electrical codes and safety regulations. Ensure proper grounding and bonding for the enclosure. Use wire with a higher voltage rating than the operating voltage for added reliability and safety margin. Consider using a qualified electrician for installation and verification. When selecting wire, consider the ampacity, which is the current carrying capacity of the conductor. The NEC provides tables, such as NEC Table 310.15b16, that list the allowable ampacities for various wire sizes and insulation types based on temperature ratings and installation conditions. For a 2 amp load, even the smallest allowable wire sizes, like 14 American wire gauge, or AUG, copper, or 12 American wire gauge, or AUG, aluminum, will have sufficient ampacity. However, it's good practice to choose a wire size that provides some safety margin, especially if the installation conditions might lead to higher temperatures. The insulation is a critical factor in high voltage applications. Cross-linked polyethylene, or XLPE, and ethylene propylene rubber, or EPR, are common choices for high voltage insulation because they offer excellent electrical properties, heat resistance, and moisture resistance. These insulation types are designed to withstand the electrical stress associated with high voltage systems. When choosing the insulation, check the voltage rating of the wire. Ensure that the wire's voltage rating is higher than the operating voltage of the system, which is 5 kV in this case. This provides a safety margin and helps prevent insulation breakdown. The jacket provides mechanical and environmental protection for the insulation. Polyvinyl chloride, or PVC, is a common jacket material that offers good resistance to abrasion, chemicals, and moisture. Low smoke zero halogen, or LSCH, jackets are often used in enclosed spaces or areas where smoke and toxic fumes could be a hazard in the event of a fire. The selection of the jacket material depends on the specific environmental conditions of the installation. Since the wiring is contained within an enclosure and not directly connected to the 5 kV bus, stress cones are not required. Stress cones are typically used at the termination points of high voltage cables to reduce electrical stress concentrations. They are essential when terminating cables directly to equipment like transformers or switchgear. However, in this scenario, the wiring serves as a connection within the enclosure, and the terminations are not subject to the same level of electrical stress. Fusing and circuit protection are essential for protecting the wiring and equipment from overcurrents and short circuits. The 2 amp fuse specified for the potential transformers, or PTs, is intended to protect the instruments themselves. In addition to the fuse, consider using a circuit breaker or other overcurrent protection device to protect the wiring and the enclosure. The size of the circuit breaker should be based on the ampacity of the wire and the requirements of the NEC. Grounding and bonding are critical safety measures. Proper grounding ensures that any fault current will safely flow to ground, minimizing the risk of electrical shock. Bonding involves connecting all metal parts of the enclosure and equipment to create a low impedance path for fault current. This helps to ensure that the protective devices will operate correctly in the event of a fault. Always follow all applicable electrical codes and safety regulations. The NEC provides detailed requirements for wiring, grounding, and overcurrent protection. Consult the NEC and any local codes to ensure that the installation meets all applicable standards. For added reliability and safety margin, consider using wire with a higher voltage rating than the operating voltage. For example, you could use wire rated for 8 kilovolts or 15 kilovolts, even though the operating voltage is only 5 kilovolts. This provides an extra layer of protection against insulation breakdown. While it is possible to perform the wiring and connections yourself, it is always recommended to use a qualified electrician for installation and verification. A qualified electrician has the knowledge, skills, and experience to ensure that the work is done safely and correctly. They can also identify any potential problems and make recommendations for improvements. When selecting the wire size, consider the ambient temperature and the number of conductors in a raceway or cable. The NEC provides adjustment factors for ampacity based on these factors. If the ambient temperature is high, or if there are multiple conductors in a raceway or cable, the ampacity of the wire may need to be derated. Ensure that the wire size is adequate for the actual operating conditions. Also, consider the voltage drop in the wiring. Voltage drop is the reduction in voltage that occurs along the length of the wire due to the wire's resistance. Excessive voltage drop can cause equipment to malfunction. The NEC provides guidelines for voltage drop. Calculate the voltage drop in the wiring to ensure that it is within acceptable limits. If the voltage drop is too high, you may need to use a larger wire size. When installing the wiring, use appropriate connectors and terminations. Ensure that the connectors are rated for the wire size and type and that they are properly installed. Loose or corroded connections can cause overheating and electrical problems. Also, protect the wiring from physical damage. Run the wiring in conduit or other protective raceway to prevent damage from abrasion, impact, or other hazards. Label the wiring clearly to identify its purpose. This will help to prevent confusion during future maintenance or troubleshooting. Use wire markers or labels to identify the circuit number, voltage, and other relevant information. Finally, inspect the wiring regularly for signs of damage or deterioration. Check for cracked insulation, loose connections, and corrosion. If you find any problems, repair them promptly to prevent electrical hazards. Regular inspection and maintenance can help to ensure the long-term reliability and safety of the electrical system. In summary, select the appropriate wire size and type based on the NEC and the specific application requirements. Use cross-linked polyethylene or XLPE or ethylene propylene rubber or EPR insulated wire with a suitable jacket. Since the wiring is within an enclosure, stress cones are not required. Provide appropriate fusing and circuit protection. Ensure proper grounding and bonding. Follow all applicable electrical codes and safety regulations. Consider using a qualified electrician for installation and verification. By following these guidelines, you can ensure a safe and reliable electrical connection for the potential transformers, or PTs, and the 5 kilovolt bus. Remember to consult the NEC for specific requirements and to consider all relevant factors such as ambient temperature, voltage drop, and installation conditions. Safety should always be the top priority when working with electrical systems.